Hello everyone. Today we're going to be going over another Further Pure Maths IGCSE past paper question. So this question is about, well, it's a calculus question, and the task here is to just differentiate with respect to x. It's question 5 of the January 2012 paper 1, and this part of the question carries 2 marks, and this part of the question carries 3 marks. So, two-part question, fundamentally asking us to do the same thing for both of these functions, so let's just get right down to it. For the first function, we've got y is equal to x squared e to the x. Differentiating the left-hand side is easy because it's just dy dx. They don't want you to do anything more. But for the right-hand side, because it's one function multiplied by another function, you're going to want to use the product rule. So let's call this u and let's call this v. And recall that the product rule states that if you are differentiating two functions multiplied together, uv by x, it's equal to v du over dx plus u dv over dx. And let's explore why this is the case, because say you have multiplied all of these sides by dx. You're just looking to prove that duv is equal to v du plus u dv. This is illustrated in another video on my channel called Why is the Product Rule, but I'll explain it again here. Say you have some rectangle where one side is u and one side is v. The area of this rectangle, y, represents the two functions multiplied together. When you increase both u and v by some tiny amount, some infinitesimal or infinitely small amount, where the change in u is called du, because a lowercase Roman d stands for infinitesimal change, and the change in v is called dv. If you increase the side lengths by that amount, you will also eventually get an increase in the area of the rectangle, where this is u, this is du, this is dv, and this is v. And basically, the sum of these three areas is dy, because dy is the change in the area after an infinitesimal change in du and dv. And dy being equal to duv, as we describe here, comes out of an interesting place. So dy is basically equivalent to the area of this rectangle, which is v times du, plus the area of this rectangle, which is u times dv, plus the area of this square, which is, well, it's not really a square, it's a rectangle, because it's only a square if u and v are exactly the same, or du by dv is 1. But, anyway, for the purposes of this question, that doesn't matter, because it's du by dv, du multiplied by dv. So, why do we get from this to only two terms here? Well, it's time to consider something about very small numbers. Say dy is like some actual change in y, using a lowercase delta to represent a small but finite and non-zero change in y. Let's call this a small number. If this is a small number, then surely we add up small numbers to get to the small number, right? So v is a typically sized number, like maybe it's 2 or 8 or 16 or something, and du is also a small number. So this is small. And at the same time, u is a reasonably normal sized number, so normal, and dv is small. So this number is a small number, this number is a small number, and this number is also a small number. So we're on the scale of small numbers here. But the thing is, this last number, it's a small number multiplied by a small number. And I'm going to call this a tiny number because even when looking on the scale of small numbers, if you were to divide a small number by a small number, you'd get a reasonably sized number. But dividing this tiny number by a small number still gives you a small number. So this kind of equation is sort of like adding 6 is equal to 4 plus 2 plus 0.0000001 with infinite zeros here. That's the sort of equation we're working with here. And in the end, du multiplied by dv is so small compared to vdu and udv, especially considering that the formal definition of a d something, like du or dv, actually just means 0. This becomes 0 no matter what, and so this term is actually ignored in the product rule. And that's why the product rule is the way you see it here. duv is equal to v du by dx and u dv by dx. So if I'll just clear the board a little bit and move this back because I had a pen error there. We have our y is equal to x squared e to the x, and we'll call this u, we'll call this v, and now we'll apply the product rule. An easier way to write the product rule is that uv prime, where this apostrophe symbolizes differentiating with respect to x, uv prime is equal to v times u prime plus u times v prime. So let's just write all of these values out because it makes doing these calculations a lot simpler. We have u, v, u prime, and v prime. Prime is how you pronounce the apostrophe, by the way. So u is x squared, differentiating x squared by moving the 2 down here and getting the new exponent being 1, via the power rule that is. U prime is 2x. And v being e to the x, of course when you differentiate e to the x, you still get e to the x. That's your differential of e to the x with respect to x. So we multiply these two, and u prime v is 2x e to the x. So 2x times e to the power of x plus u times v prime. So x squared multiplied by e to the x. You don't need to draw these arrows here and there in your working because the examiner will know that that's what you're doing since you've written your formula out here. Plus x squared e to the x. Or if you would prefer to write it in a simplified form, is equal to e to the x, x squared plus 2x. And that's our answer for part A. Now let's move on to part B. I'm going to move this up because I want a little bit more space. For this differentiation exercise, we're going to be using the chain rule. And the chain rule is something that shows that if you have a function where y is equal to some function of x, but you can express it in this way, so it's g of h of x, some function of another function of x, or what people like to call a composite function, especially in this case where you have your function h of x being x cubed plus 2x squared plus 3, and then your g is x to the 5, so applying this function to the power of 5 is a sort of composite function that we'd use the chain rule to deal with. Then if you were to differentiate both sides, then y prime is equal to d gx by g by dhx multiplied by dhx I apologize, this is incorrect. If y is a function of u, where u is a function of x, then if you differentiated y, you'd find that dy by dx is equal to dy by du multiplied by du by dx. And why is this the case? Because if you were to treat a differential as a fraction, one infinitesimal change divided by another, then these du's would be equal and they would cancel out. A pure mathematician would scream at me for doing such a thing, but hopefully this provides some intuition for you, because as far as my education has gone at the time being, I can kind of see why this makes sense. So when this represents differentiating y with respect to u, and this is differentiating u with respect to x, these du's are equal, cancel out, and allow us to use the chain rule for this kind of thing. So, of course, this has been a lot of abstract information, and I hope to apply this chain rule for you to actually see for yourselves. So what will we do? Well, let's let u be the function inside these brackets. U is equal to x cubed plus 2x squared plus 3. In this case, y is equal to u to the power of 5. So instead of finding dy by dx directly by expanding all of this brackets, which you could potentially do but would be an incredible waste of time, you can instead get this y is equal to u to the 5, differentiate it with respect to u, so on one side, on the left side, you get dy by du. On the right side, u to the 5 by du becomes 5 times u to the 4 because of the power rule. This 5 goes down and is replaced by the exponent 1 below it. dy by du is 5u to the 4. Remember, that's 5u to the 4, not 5x to the 4, because you're dealing with u here. And you get your du by dx, given that u is equal to x cubed plus 2x squared plus 3. Well, first the x cubed term goes to 3x squared by the power rule, bringing the 3 down to the left. And finally the 2x squared becomes 4x, bringing the 2 down to the left with the power rule. And 3 as a constant is eliminated from the situation entirely. So dy by du is 5u to the 4, and du by dx is 3x squared plus 4x. We multiply them together and we get dy by dx is equal to 5u to the 4, 3x squared plus 4x. But that's not actually completing the question yet, because we're still with mixed variables here. We want it all to be in terms of x, so we can get dy by dx in terms of x. That's kind of what people are looking for when they ask you to differentiate something like this. So let's resubstitute this function of x back into u, where we have u right now. And dy by dx becomes 5 times x cubed plus 2x squared plus 3 to the power of 4, multiplied by 3x squared plus 4 to the x, plus 4x. And in these kinds of differentiation questions in further pure maths, you don't actually need to simplify it beyond this, generally speaking. Only if they explicitly ask you to simplify it or show that it can be made in some form will you need to do that. So this is a valid answer, and this is our final answer for part B of the question. I hope that was helpful for you if you had questions about differentiating functions like this. Thank you for listening, and if it helped you, please do subscribe to the channel. There's a new video every Sunday, Tuesday, and Thursday at 6 p.m. Hong Kong time, which is at 10 a.m. Universal Coordinated Time, or GMT, or UTC, which should be around early to middle afternoon for the bulk of my non-Hong Kong viewers in Myanmar, Bangladesh, and Africa. So, until next time, thank you for watching.